equals to x plus 9. So now you just solve for x. First thing, by distributing, so it'd be 2 times 2x is 4x, minus 2 times negative 3 is 6, negative 6. And then on the right side is just x plus 9. Now subtract x to both sides. We get 4x minus x is 3x. Bring down the negative 6. Haven't done anything to it. Here x minus x cancel out. Is just 0. You bring down the positive 9. Now add 6 to both sides. You get 3x equals to 9 plus 6 is 15. Now divide both sides by 3. You get that here the 3 cancel out. X equal to 15 divided by 3 is 5. For the next triangle SRQ, you can see that YZ is the mid-segment. SQ is the parallel side of the triangle to that mid-segment. So to solve, always first multiply the mid-segment by 2 and set it equal to the parallel triangle side. So now we distribute. 2 times x is 2x. 2 times 2 is 4. The right side stay the same. And now subtract 2x to both sides. You'll get that 2x cancel out and be 4. 3x minus 2x is just x minus 8. Add 8 to both sides. You get that x equals to 12. For number 8, we have to find the segment VW. Earlier example, all we had to do was find x. But this time we have to find the measurement for the segment VW. We start with the same method. So here, VW is the mid-segment. The parallel side of the triangle to VW is NL. So once again, first multiply the mid-segment by 2 and set it equal to its parallel triangle side. Now distribute the 2. You'll get 2 times x is 2x plus 2 times 15 is 30 equals to x plus 21. Subtract x to both sides. You get that 2x minus x is just x. Bring down the positive 30. Here x minus x is cancel out. It becomes 0. Bring down the 21. Now to solve for x, subtract 30 to both sides. You get that x equal to negative 9. Now we're not done. We have to find the measurement of VW. So once we found x, just substitute x into the measurement of VW. VW here equals to x plus 15. So VW is negative 9 plus 15. Negative 9 plus 15 is 6. So VW. Number 12 asks us to write the equation of a line containing the median to AC. So let's say if I have a triangle A, B, C, and a median to AC means that the midpoint is on the segment AC. So if you remember the definition of midpoint is from vertex to the opposite side, midpoint. So to find the equation, we first must have to find the midpoint of AC. To do that, as you remember the midpoint formula, it is x2 plus x1 divided by 2, comma, y2 plus y1 divided by 2. So So here's point A and C. I'm going to plug these numbers into my midpoint formula. I'll get, again, negative 8 plus 0 divided by 2, negative 6 plus 2 divided by 2. So my midpoints turn out to be negative 8 plus 0 is just negative 8 divided by 2 is negative 4. Negative 6 plus 2 is negative 4 divided by 2 is negative 2. So this is my midpoint. So once I find my midpoint, I can now find the slope of the median by using the midpoint and the vertex B to find the slope, plugging it in the slope formula. So slope formula is m equals to y2 minus y1 divided by x2 minus x1. So let this be my x1, y1. B is x2, y2. So plugging it in, I'll get 4 minus negative 2 divided by 6 minus negative 4. 4 minus negative 2 is the same as 4 plus 2. 6 minus negative 4 is the same as 6 plus 4. So 4 plus 2 is 6. 6 plus 4 is 10. I can simplify this 3 over 5. So this is my slope. My slope is 3 over 5. So once I have a slope and I have a point, I can plug it into the point slope formula. Point slope formula is y minus y1 equals to the slope times x minus x1. So here, my equation is, I'm going to use the midpoint. Y minus negative 2 is basically y plus 2 equals to the slope, open parenthesis, x minus negative 4 is the same as x plus 4. That's one of the answer. If you choose to use the vertex B, then you'll have y minus 4 equals to 3 over 5 x minus 6. And those are your answers. Number 13 asks us to write an equation of the line containing the altitude to AC. So once again, if you remember, definition of altitude is from the vertex to the opposite side, creating a 90-degree at the intersection. So this AC, that's B. So to find the equation of the altitude, we must first find the slope of AC. So once again, using the slope formula and using the coordinates from point A and point C, I'm going to plug that in. So I have negative 6 minus 2. This is my slope. So negative 6 minus 2 divided by negative 8 minus 0. Negative 6 minus 2 is negative 8. Negative 8 minus 0 is negative 8. So my slope here is 1. So this slope from A to C is 1. But we know that from the definition, the altitude slope is perpendicular to this slope. So that's what we're going for, the altitude slope. So it's perpendicular. If you remember, to find the perpendicular of a slope, you just flip it and change the sign. So imagine if this is 1 over 1. Flip the 1 over 1, you still have 1 over 1. If this is a positive, it becomes a negative. That is the perpendicular slope, or I can just write it as negative 1. Now, you have a slope and you have a point. Just plug it into the point slope formula. So the point slope formula is y minus y1 here is 4 equals to the perpendicular slope that we found, minus 1 open parenthesis x minus x1, which is 6. So that is your equation. Number 14 asks us to find the equation of the line containing the perpendicular bisector to AC. If you recall, here's my triangle A, B, C. The perpendicular definition is it bisects, right? It bisects meaning splitting AC into two equal parts. So here it must be a midpoint. It also creates a 90 degree at the intersection of the side with the segment. So all we really need is the perpendicular slope of AC and also the midpoint of AC. And we have found those information earlier on question 12 and 13. And the perpendicular slope of AC is -1. The midpoint of AC was -4, -2. So once we have a point and a slope, we can just plug it into the point slope formula. Well, the point slope formula said is y minus y1. y1 here is -2, so y minus a -2 becomes y plus 2 equals to the slope, the perpendicular slope, that's -1, open parenthesis, times x minus x1. x1 here is -4. X minus the -4 would change it to x plus 4, and that is your answer.